That's only why it's like.
All right, let's get started. You have an assignment out, so PS5 is out. It's due Thursday, as usual. Then PS6 will come out and be due right before fall break. And then there's fall break, and the week after fall break will be the midterm. So there will not be an assignment due the week of the midterm. Which means, after you finish PS6, it'll be 3 weeks until your next assignment. So between fall break and the week of the midterm, you sort of get a break there. Are there any questions or problems about anything before we proceed? In particular about PS5? Yes?
If we have a question about using one of our core late turn-ins, should we email you personally or post it in the discussion tab?
You have a question about how to use a link?
Well, not how to use it, but if we have issues. Like, I heard you mentioning to someone that if you need like an extra day, 2 days or something, to come talk to you, and you can get those out.
Yeah, I mean, if an emergency comes up and you need, you need an extension, if you can make a good case, I can give you one. But yeah, you just need to come talk to me. Other questions? Yes?
Does it say what the intermediates in the syllabus?
Say again?
Does it say what kind of test the intermediates in the syllabus? Or
Well, okay, asking what kind of test the midterm is. I can just tell you the midterm will be short answer. You might write little snippets of code, nothing major. You'll read code, you'll answer questions. All short answer, easy to grade. I will give you a sample midterm the week before fall break, which is next week. One caveat is, this is the first time I've taught this class in a while, 2 days a week. More recently I was doing it 3 days a week. And with the 3-day-a-week schedule, I have 2 midterms. And this is only one midterm, so it's not going to be a nice matchup between an old midterm and a new midterm, but I'll do my best. Yes?
Are there going to be any definition questions?
Any definition? She's asking, are there going to be any definition questions? Well, it depends what you mean by definition.
Like, are you going to give us, like, I don't know, any certain term and just ask us to write out a definition for it?
Well, okay, so yeah, I expect you to know the terminology we've been using. So basically anything that we cover through this week and through problem set 6 is fair game, whether it's in the reading, the labs, the lectures, the assignments, whatever. But you'll get a better idea what it'll be like when I give you a sample. Any other questions? Yes?
Is it online or paper?
Well, it's paper. It'll be crowded. I mean, right now we're probably getting, 200 people here, but there's over 300 people registered. So they'll presumably be here. So be crowded.
Is the question not kind of just trying to generalize it, but is the question layout going to be like around arrays and searching loops and like for loops and stuff like that we've learned in this class? In the generalized sense.
Yeah. So he's asking sort of what topics. Anything through this week of the class. Typically, when I make up the exam, I say, okay, we covered counting loops. Let's put a counting loop question on. That might not be write a counting loop. It might be, here's a problem. Is this solved by a counting loop or a searching loop? Something like that. I just try to think of some way to hit the major topics that we've done. And my goal is questions that don't require a lot of writing, because we don't like to read a lot of writing. We like to be able to grade quickly. Go do what we're going to do. Yeah?
Would you recommend study groups?
Do I recommend study groups? Yeah, I think they're a great idea. I mean, my feeling about the exam is if you've been paying attention and doing well in the exam, on the assignments, it shouldn't take, heroic efforts to study and prepare. It ought to sort of just be natural. One thing, you can bring a sheet of notes. I guess I should mention that.
All right.
Okay. So I don't want to make it a test of memorization. You can write down what you think is important and bring it with you.
A full page?
A sheet?
Yeah, a full sheet of notes front and back.
What's the dimensions
What's the dimensions?
of the sheet of paper?
Just a sheet of paper, 8.5 by 11.
That is a big factor,
8 by 11, normal size. Don't bring a poster in.
I see people are excited about that. Glad I remember. Another question, yeah. Okay, if you're having trouble with the plugin, come see me after class and I'll see what's going on. Yes?
Will we get that sheet for the final as well?
You get 2 sheets for the final. So keep that 1 sheet and add another one for the final. Yeah. I'll decide whether it has to be handwritten or not. I'll let you know. Yeah. It's front and back. You can write as small as you want. Yes?
How many questions will be on it?
How many questions? I usually aim for 25 4-point questions. My idea is I don't want any one question to be worth too much. So, I don't want you to bomb the exam because of one question. So I like lots of short questions. Okay, now, the variety of things I want to do today. First, I'm going to answer his question. Yes?
Is there a sample exam you'll post?
I will post a sample exam, yeah. Probably, I'll do that next week. Okay. I want to first make sure that that we all understand the assignment. So, the basic idea behind the assignment is there's a write-up here that describes the general idea. The general idea is this. You can take a book, in my case I'm talking about Pride and Prejudice, and you could look and see how frequently every character occurs in the book. By character I mean A, B, C, D, every letter. And then you could randomly generate letters based on those probabilities. Now if you did that, you'd have lots of E's and fewer Q's, and you'd have a lot of spaces. And if you do the probabilities right, you would end up with something where the word lengths were about the same as they are in Pride and Prejudice, and the line breaks came about the same place. But it'd be complete gibberish. In the assignment I mentioned that you can do a more detailed analysis. Let's say you did an analysis and you figured out for every 5-letter sequence of letters, what's the probability that any given letter will be next? So in Pride and Prejudice, if the probability that if the first 5 characters are E-L-I-Z-A, B is going to be the most common letter that follows E-L-I-Z-A because Elizabeth is the main character. So you can, to make a long story short, if you do that kind of analysis, then you pick 5 letters to start with, you randomly pick the next letter based on these probabilities you've computed, and that's the first letter of your output. Now you shift over and that letter you just spit out becomes the last letter of the 5-letter window. You generate the next letter and you keep shifting it over and you end up generating random text based on Pride and Prejudice. But if you read it at this level, at level 5, it starts to sound, you can tell it came from Pride and Prejudice as opposed to some other book. If you go up to about level 8, where you're basing every letter on the 8 that preceded it, it almost starts to make sense. If you go to level 20, something like that, you just end up copying long passages of the book. So you're going to sort of have some fun and play around with it, and in doing it, you're going to have to do 2 things. One is to implement some methods that help with this algorithm. So I provide the top-level method in the algorithm. You've got to implement 4 helpers. And the other thing is to create a user interface that's bulletproof, that doesn't crash when the user messes up, that takes various inputs and generates the text and displays it. So that's all displayed in the assignment. But the key things are the 4 helpers. And the helpers involve probabilities. So let me just say here. Here's a simple one, choose substring. So you can see that you're given a string called text, a length called length, and a random number generator. And you're supposed to choose a random substring from text of the given length and return it. So if you have I don't know, 500,000 characters in your string, which might be the length of Pride and Prejudice, probably shorter, and I ask you for a random 5-letter substring of that, how do you go about doing that? How do you pick a substring at random? Yeah?
Just set the argument of the substring method to the outputs of the random integers.
Okay, well, let's think about it here. He said we use a random number generator. How many substrings are there in here? Length 5. Let's let this be length 100. Suppose you have a string of length 100. How many 5-letter substrings are there? What's the first one? Yeah, the first 5 characters here, that's a substring. What's the next substring of length 5? You just shift it to the right one. So there's the other one, there's the next one, and so on. How far can you go before you run out of string? So you've got the substring that begins at index 0, a substring that begins at index 1. Where does the last one start? Okay, so there's one that starts at 95, and it includes the letters at 96, 97, 98, and 99. So the last substring starts at 95 and goes through 99. The first one starts at 0 and goes through 4. So you've got, in all, you've got 96 substrings. So how do you pick one at random? Yeah?
You can use random number generator between 0 and in this case 95 as the starting index, and then
Okay.
you can add it, and the ending index could be whatever length you want plus that.
Right. So basically, you've got to pick a substring at random. You just got to pick a starting point at random. So you've got to pick a random number between 0 and 95. Use that. So let's say you pick 50. Use that as a starting index and pull out this 5-letter substring that starts there. And the object I'm passing in is it has a method that will generate a random integer between 0 and anything you choose. So don't freak out when you see this specifications that say you've got to pick things at random. You're getting a random number generator to use. Just use it. It'll pick a random integer for you. And then you can make a random choice. Yeah?
Are we picking a random character out of the substring or out of the entire thing?
Well,
the entire string?
this is just part of it. This method the way it'll be used is you'll take the whole text of the book and you got to pick a random substring from it. There's another method that uses randomness as well. But if you carefully implement the things that specify, the overall method will work and generate random text. Yeah?
If I'm not mistaken, the random number is made in your method and it's passed in.
No, it's not. The random number is not made in my method. The random number generator is.
Okay.
So I'm passing in an object of type rand. It has methods. The important one is next int. So if you have a random number generator, R, there's a method where you can say, for example, if you say next int of 10, it'll give you a random number from 0 to 9. So in this case, we would have wanted to get next int of 96. That would give us a number from 0 to 95. Yeah?
Then how would you build a test case? If you were not going to use the example you provided, but if you're going to build other examples?
Okay, so he's asking how you would test this. And it's not easy to test it thoroughly. You could certainly test it and make sure that the string you get back is actually a substring of the original and as the right length. If you really want to test it, what you do is maybe take a string of length 10, make a string long enough so there's 10 substrings, and you would just, in a loop, you'd keep asking, give me a random substring, give me a random substring. You would count how many times each substring was given back to you. And let's suppose you did this 1,000,000 times. How many times do you expect the first substring to show up? Or how many times would you expect each substring to be given back as the result, if they're being picked at random and there are 10 of them? If you flip a coin 1,000,000 times, how many heads do you expect? About 500,000. What if you flipped a 10-sided coin? 1,000,000 times. How many times would you expect each side to show up?
100,000.
About 100,000. And that's what's happening here. If you're trying to pick from among 10 substrings, you're essentially flipping a 10-sided coin. So you just count how many times each substring is given back, and you expect it to be around 100,000. So you throw some slop in there. You say, oh, between 75,000 and 125,000. That's sort of how you test it. Yeah?
So I'm not really sure I understand like the main like end goal of this assignment. Like so.
Well, he's asking what the main end goal. To complete the assignment, you implement 4 methods I've specified. Then together with those 4 methods and one I've given you, you will have a method which will suck in a complete book and generate random text based on that book. And once you have that method, then you implement a user interface that interacts with the user to obtain the book to use and the length, the level of the analysis, and the number of characters to output, and generates it and spits it out, spits out the result. Yeah?
So if we're going up to a certain level of the analytical method or whatever, every time we run it, is it going to come up with something a little new?
Yeah, if you do this right, every time you run it, something different will come out. Yes?
Will it be harder and harder to understand the text that's actually being spit out the more levels you get into?
No, the higher the level, the more and more it'll look like the book.
Oh, okay.
And if you get a high enough level, it will be the book. But where it's fun is when you're in this sweet spot where what comes out is definitely English words and sensible English phrases, but it's, not quite right. Sometimes you get hilarious things out when you do that.
Did you get this assignment from Ellen? From Ellen?
No. No, there was a student, though, that had a student in this class 20 years ago. We did this assignment. And he went on to go to grad school, and he's a professor now, I believe, at Berkeley, either Berkeley or Carnegie Mellon. He just won a big award, big research award. One of the first things he did, one of the first research papers he wrote, was he took this idea of random text generation and applied it to graphics. So in graphics, you got this problem where sometimes you need a background pattern that isn't, it doesn't matter what it is as long as it looks sort of natural. And he basically used this idea to create random patterns to be in the background of animations and graphics and such. So you got that inspiration here. Interesting thing. Okay, so I'll leave that. And I briefly want to finish up something that we did last time. We started last time. Let me make this a little bit bigger. Okay, this is a method that was supposed to do some, compute some numbers and then output them to a file. And this is the only thing we didn't get to last time, and that was how to write to a file. So let me show you how to do that. You can see up here at the very bottom where it says save the results. That's what I want you to focus on. So this output file right here is a file object. And it was picked using the file browser that's in the dialogues class in the CS1410 library. So there are all kinds of ways to create output. One way is with a print stream object. So you can create a print stream object by passing a file to the constructor. So you see, we take the file we want to write to, we create a print stream object from it, and we call that output. And then, to print a line, you just say output.println, just as if you're doing system.out.println, except the output will go to the file instead of to the console. So it's really simple to write output to a file. That's my point here. Now let's just remember, why am I opening the file here in that try? What's important about that? Yes?
Because if there's not a file to open, then you will throw it.
Well, he said if there's not a file to open, it will throw an exception. That's true, but the exception is not handled here. I think the method just throws an exception. But there's another reason we're opening it that way. Yeah?
When you open the file using the try block, it'll automatically close the reader after the try block.
Right. The point is, opening it this way, put in the open in parentheses after the try, when the block is exited, the file is automatically closed, no matter how the block is exited. If there's an exception thrown, if it falls through the bottom normally, whatever, the file is closed. So anytime you have an object that can be opened and closed, you want to open it with one of these tries, so you don't have to worry about closing it. It's just, yeah.
So is that really just like handling warnings, kind of?
Is what handled in warnings?
So like you're saying that automatically closes it. Like what's like the problem if it isn't closed together? It's like, is there an issue with that or?
No, you can trust that it will be closed. The language is guaranteeing you it'll be closed no matter what. So you don't have to worry about figuring out all the ways in which you might need to close it.
I just wanted to clarify his question. He was saying, what would be the problem if it's not closed?
Oh, what would be the problem if it's not closed? Well, in a short-running program that just runs for a second and then ends, no problem. Because when a program ends, all the files that it have open are closed. But if you have a program that's meant to run for a long, long time, like let's say a web browser, if it keeps opening files and not closing them, there's only so many files that can be opened by a process before it can't open anymore. And so gradually it would open files. Other programs wouldn't be able to open those same files because the web browser have them open. So it's just best to be in the mindset that you always want to close what you open. You learn that in kindergarten, so it applies here. Is there a question back there? Yeah.
So would you recommend using Flatlock for scanners in the future? Or?
Sure. Yep. So he's asking about scanners. If you're going to open a scanner, open it in one of these try with resources things. Then you won't get that little yellow warning anymore. Yeah.
Would you like us to use PrintStream specifically, or can we use other things like buffer drivers?
Yeah. So he's asking about other things. So I picked PrintStream here because system.out is a PrintStream object. So my thought was, okay, you know how to use system.out to print stuff. It's just exactly the same thing here. What he just said is there are lots of there are dozens of input-output classes in Java. One of them he mentioned just now was buffered writer. So yeah, you can use whatever you want. There are lots of choices. I know when I haven't programmed in Java for a while, I have a hard time remembering what they all are. I end up having to look them up just to remind myself. But yeah, there are lots of choices. Okay. Next thing I want to do I want to look at some solutions to old assignments. So all the solutions to PS2, 3, and 4, along with the test cases we use for grading, are sitting in today's project. And the TAs told me of common mistakes they've seen. So I wanted to show you, I don't have time to go over every single solution, but I want to show you some of them and talk about them with you so we can clear that up. And I think this is a good place to start. So this one is supposed to say if a string returns true when a string S contains the token T. So first of all, I think there's some misunderstanding. What is a token? When I say token, what do I mean? Yeah?
It's a thing surrounded by two white spaces, whether it be a word or a number. Or
Okay, so he said a thing surrounded by white space. Essentially, that's right. It's whatever a scanner gives you back when you say next. Right? So when you create a scanner, you create a scanner out of the string, and you say next, next, next. It's giving you one token after the other. And what it's doing is it's just reading text till it sees a white space break, and it gives you everything up to that white space. All right? So let's see. I create a scanner, and then I say while it has a next, while there is a next token, I scan it and see if it's equal to T. And if it is, I return true, and if it's not, the loop continues. And if we fall through the loop, we return false. Now, what kind of loop is this? It's a searching loop. What's it searching for? Okay, go ahead.
Token is equal to the string t.
It's searching for a token that's equal to the string t. Now, the TAs tell me that a lot of you don't do that. You do that. You test for equality between two strings by using double equals. Okay? Don't do that. It is never, I hate to say never, but it's almost never the right thing to do to test for equality using double equals. Test for equality of strings, or more generally of objects. Use double equals for testing quality for primitives. For strings, use dot equals. Okay? Double equals, you're asking, are these two strings stored in the same place in memory? Which is to say, are they physically the same string? But you could have a string hello stored over here, and a string hello stored over here. Same letters, they're not double equals because they're stored somewhere else in memory, but they are dot equal. Another thing they told me you were doing, a lot of you, was that. Testing for equality with dot contains. Okay? What does dot contains do? Okay?
It only checks if t is present in some part of scanner.next.
Right, it's taking the token from scan.next and seeing if t occurs as a substring of it. So it's true that if two strings are equal, one will contain the other, and vice versa. But it's not true that if one string contains another that they're equal. So they're not comparable things. So you want to use equals, not contains. All right, let me show you another one down here. This is find most white space. So in this one, as you recall, you're given a scanner. You're supposed to pull lines from the scanner, find the string with the most white space in it, and return how much white space it contains. So what kind of loop is this? It's an optimization loop, because you're looking for, I mean, the word most is the giveaway. You're looking for, you're optimizing something. And so you expect to find it structured like an optimization loop. And so what you can see is that we start with our best so far, which I call most so far, and I set that to -1. I do that because the specification says if there are no lines, I need to return -1. So that's my default value. Any line that I find is going to have more white space than that, unless there are no lines. Yeah?
Couldn't, for the Java doc up in the blue right there, couldn't you have just copied and pasted exactly what you told us to do, and then put it right there?
I was asking, could you have copied and pasted the text from my assignment? Yeah. The text.
It's better to write your own, of course.
So the thing is, the text in the assignment isn't exactly the way I would write Java doc, right? But it's perfectly fine as a first attempt. We would accept that, and we accept about anything that's close as long as there's something there. The important thing is to have something there. Okay, so now I'm looking at every line. So while there's a next line, I grab a line. And what's going on here? Yeah?
Is that a helper method?
Okay, I wrote a helper method called count whitespace. It takes in a string and returns how much whitespace it contains. A lot of you apparently wrote another loop here. Wrote a counting loop. Instead of calling a helper method, wrote a counting loop to count whitespace in line inside the while loop. So you have nested while loops. It's certainly possible to implement it correctly that way. But if you are having trouble writing singly nested loops, and by definition, since this is the assignment where you practice, most of you do have trouble writing singly nested loops, it is a fundamentally bad idea to compound the problem by writing a doubly nested loop. You need to practice what I call wishful thinking. You get to this point and you know, yeah, I need to know how much white space is in the line. And then if there's more white space than most so far, most so far becomes that bigger value. And you say, you know, if only this method existed, my method, I would be done with find most white space. Then you make your wish come true. You implement the method. Let's try to think of some advantages of writing a helper method instead of trying to write a nested loop right here. What's good about writing helper methods? Yeah.
Use them anywhere else.
Okay, one good reason you write helper methods is once you've got that helper method written, you might be able to use it in other places. It's easy to reuse methods, not so easy to reuse a nested while loop. Yeah?
They make it clean and easy to understand what's going on.
Okay? It makes this method a whole lot easier to understand because rather than there being another loop in here, which would make me dizzy, there's just a call to a method, and it's obvious what the method does, either from the name or from the Java doc. So it makes this method simpler to read, simpler to convince yourself it's correct.
It's easier to test that your helper method works.
Okay.
Than to test that your real method works.
That's very important. Methods are easily testable. So you've got two things going on here if you nest a loop. You've got to wonder, am I counting white space correctly? And if, assuming I'm doing that, am I computing the maximum amount of white space correctly? If you split it up into helper methods, you can first test count white space and convince yourself that's working right. Once you're sure that's working correctly, then you don't have to worry about this being wrong right there. You just test that method. That's a big payoff. You can test them separately. JUnit is set up to make it easy to test methods. Now, I think I know why people nest loops. It's because they think, you know, my assignment is to write methods. Why in the world would I make my assignment harder by writing even more methods? Okay? That's backwards thinking. Methods are what make programming easy. Imagine if some big program was just one main method. Take Eclipse. Eclipse is a big Java program. What if all the code was in one method? It's unimaginable. You'd have like a 1,000,000-line method. It would be impossible to test and impossible to understand. Breaking up programs into methods is a key part of making programming simple. So if you're ever tempted to write a doubly nested loop, it's okay. Eventually you'll do it. But at first I would really recommend avoid the temptation. Just write a helper. See, here's a helper method with the other loop in it. You have a lot better chance of getting it right. Okay? Yes?
Is that an accumulation loop or a searching loop?
Okay? What kind of loop is this right here? Accumulation loop or a searching loop? It's accumulation loop. It's basically, I mean, I think sometimes I call this a conditional accumulation loop. It's combining everything together, but it's ignoring a lot of the things. It's just counting white space. So you can have an accumulation loop with an if. What would be the giveaway that this was a searching loop? There would be a loop with a conditional, but what kind of conditional would there be? Yeah. Yeah, there'd be a return in the conditional. That's what a searching loop would look like. Yeah.
On the test, these verbs you're using accumulation loop, optimization loop, all these things, they're going to be words we need to know for the test.
Absolutely, you need to know what accumulation loop, searching loop, optimization loop are. What those patterns are when you use one versus the other. Yeah?
So on the test, you asked for an example of like a certain type of code. And like at the beginning, you said a lot of people use the have or contains, and it would have been better to equals. Would you like knock off the point to say this works, but it's not the most efficient way?
It's okay. So he's asking, what if I use contains instead of equals? Would we knock off a few points and say, that's okay, but it's not as efficient? No, we would knock off a few points and say it's wrong. It's not a matter of efficiency, it's a matter of correctness.
Even if it worked?
It doesn't work.
It won't work.
I used contains and it worked. So I mean, if it works, but it's not.
Well, it worked on the test cases you used. We graded with different test cases.
Okay.
Right? You're responsible for programming to a specification, not just programming to a set of specs. Okay? And one warning. The test cases I gave you for the current assignment are just completely, totally inadequate. I just gave them as to give you, part of your assignment is to create real test cases. I just gave them there as a way to get you started or to show you a couple techniques. It's not even close to correct when it passes my test cases necessarily. They're just so inadequate. Okay? So in this project, which is, you can download with it's linked into Canvas, you can download it with a plugin, are the solutions to the last 3 assignments, PS2, 3, and 4. So I encourage you to look at them, and it'd be a great way to study. One thing the TA said was that often you get something to work, but it's a lot more complicated than it needs to be. So look at my solutions and see how it measures up to yours. See where you went wrong, maybe see a better way to do things, or maybe you can tell me a better way to do things. Yeah?
Sorry, once again, where were those solutions?
They're in today's example. The solutions are in today's examples. And every day after lecture, I link the examples for that day into Canvas, and it also becomes available with the plugin under lectures. Okay? All right, let's take a quick break and we'll look at collection classes. All right, now for those of you listening on the live stream, we're trying without a microphone today, so if it's not working, post a comment and you'll notice. Okay, now we started looking last time at array lists, and an array list is an example of what's called a collection class. So in Java, there are 6 classes, which are known as the Java collection classes. And those 6 classes are all in java.util, that's the package. They are ArrayList and LinkList, which are both examples of lists. HashSet and TreeSet, which are both examples of sets, and HashMap and TreeMap, which are both examples of maps. Now, the difference between an array list and a linked list, and the difference between a hash set and a tree set, or between a hash map and a tree map, are important, but not currently important. For the time being, you can sort of think of them as interchangeable. Essentially, they're implemented using different technologies, and when you start trying to understand what makes programs fast or slow, then the difference is important. And in fact, probably the majority of 2420 is spent studying the difference between these pairs. What I want you to understand today is what lists are, what sets are, and what maps are. And that's what we'll do. And the thing is, these are called generic types, because when you use it, you just don't say array list. You say array list, and then in the angle brackets, you give what type of thing is in the array list. So it might be array list of string, or what have you. So a real type name, the reference type name, would replace the t's and the keys and the values here. Now, we looked at array lists, and essentially what you need to know is an array list is a list of objects, all of the same type. So for example, that's sort of a picture you could have in mind of what an array list of strings would look like. It's just a list indexed from 0. You can store things in the list, you can take things out, you can add to the end of the list, you can actually physically take items out, shrinking the size of the list. It's a lot like an array, except it can grow and shrink. Yeah?
Can you remind us why we would ever use an array over an array list if they're more...
Okay, he said, why use an array over an array list? Okay, array lists are more flexible, but arrays are more efficient. So if you have the difference in efficiency is not that big a deal. But you might use an array if you really cared about efficiency and you know that you've got something of a fixed length. There are also circumstances in the Java API where a method requires an array as a parameter or returns an array as a result. You got no choice if you want to use the API. So that's an array list. Now, here's the fine print that we didn't talk about last time. The only thing you can store in an array list are objects, not primitive values. So you can't directly store integers or booleans or doubles or characters or what have you in an array list. And so this is the trick Java makes. If you want to store an int, this is what you have to do. you declare an array list not of ints, but of integers. Spelled that way. So you create a new array list. Then to store the int 5 into the array list, we first take 5 and make an integer object out of it. So that's called wrapping or boxing the 5. So we make an integer object out of the int 5 and store that in there. So we create the integer object and store that in the list. Then to get it out, you use the get method to pull item 0 out, and then you have an object that contains the int you want. And so you have to call the int value method on that object to pull the actual 5 out. So back here, this is called wrapping or boxing. This is unwrapping or unboxing. That integer class exists, so you can take an int, stick it inside an object, so it can store in one of these generic data types. Yeah?
So does it take more energy to store these, or more memory to store them as objects?
Yeah, she's asking about memory. Yeah, objects are bigger than, any object can be bigger than an int. Now, this seems like a colossal pain in the butt. You have to do this just to store an integer, an int, in a list. So, the good news is, all that stuff is done automatically, 99.9% of the time. There occasionally run into a case where it doesn't work like you think. You declare an array list of integers, just like we did. You can set item 0 of that list to be 5. And what happens is, Java takes that 5, wraps it in an integer object, and stores the integer. And when you go get the int out, Java takes the integer out, the object out, grabs the int from it, and returns that. So it's doing that boxing and unboxing for you. So you really don't have to worry about it. The only thing you got to realize is that if you want an array list of ints, you got to spell it integer with a capital I. Or program in C# where you can have array list of ints. The problem was the generics were not in the initial version of Java. By the time they worked generics in, they had sort of backed themselves into a corner where this was the best they could do without changing every JVM out there that's installed in the world. So they did the best they could. And so you just need to know what the wrapper classes are. So there they are for int, double, char, and boolean. Now, what I don't know is why they didn't just have them all just be capitalized versions of the originals. Why did, int has to be integer. It's like they want to have long formal names for things. So just remember that table right there. Yeah?
Then can you do like, can you like write an expression with like an integer object and an int?
Yeah, so he's asking, what if you have an integer object and you want to add it to 2? In fact, that will work. Java will say, oh, he's trying to add this object, it will extract the int from it and use that. So, 99.9% of the time, ints and integers are interchangeable. Java does the right thing. It either boxes the int or unboxes the object. And you don't have to write any code to deal with it. Yeah?
So that means usually when we use a get, we'll be getting an integer automatically and not an integer object?
Well, when you do a get on an array list, he's asking what will I get back? Depends what you're doing with it. If you pull something out and you're storing it in an int variable, yeah, it'll unbox it and you'll get the int. If you're storing it in an integer variable, it won't unbox it for you. It just figures out what you need. And sometimes, I keep saying 99.9% of the time, sometimes it can't tell which you mean. And then you have to do something more to make it clear. That just doesn't come up very often. Okay, so that's a list. Then there are things called sets. So in mathematics, what is a set? Yeah?
It's an unordered group of stuff.
Well, she said it's an unordered group collection of things. Okay, there's another property, important property of sets. Yeah?
Every element has to meet certain criteria.
Well, he said every element has to meet certain criteria. I guess so. In our case, it's, every element has to be of the right type. Yeah?
There's only one of each thing?
Okay, no duplicates. So you couldn't have 3 7s in a set. You just have 1 7. If you insert, so the fundamental operation on a set, once you create a set, initially it's empty, you can put things into it. And if you try to put the same thing in twice, it just ignores the second try. So you can put things in, you can remove things from the set, and you can also ask the set, do you contain this element? Is this element in the set? You can test for membership. That's what you do with sets. So that cloud there is meant to elicit the idea of a set of strings. And she said they're unordered. What that means is you don't say what is stored at index 0 of the hash set. You don't index into a hash set. You might ask, is cat in that set? The answer would be yes. You might ask, is horse in that set? The answer would be no. So that's a hash set. Yeah?
Why would you ever use this instead of a list?
He asked, why would you ever use this instead of a list? Okay? The answer is, sometimes all you want to know, you want to keep track of a set of things, and you want to be able to test whether something is in the set. If you don't have to support indexing like in a list, you can make that contains operation very efficient. So it's for efficiency purposes. If you don't need the full power of a list, you can make your program faster by using a set. And those trade-offs are the kinds of things that are talked about in 2420.
Did you already say what a hash is?
Okay, he asked, I haven't said what a hash is. Remember, there are two kinds of sets, hash sets and tree sets in Java. Hash and tree refer to hash table and binary search tree, which are the technologies that are used to represent the sets, the code behind the scenes. And we're not going to stress over that. Yeah?
Are we going to cover, are linked lists a part of this? Or?
Okay, there are two kinds of lists, array lists and linked lists. And we will get into the difference between array lists and linked lists later in the semester, sort of as a way of introducing issues you'll see in 2420. But for now, just think they're just two kinds of lists that use different technology. That's what a set is. And here's a map. Now, a map's a generic type that takes two types as to instantiate it: the key type and the value type. So you can think of a hash map, or more generally, you can think of a map as a collection of key value pairs. So here I'm saying, okay, I have, let's say the animal name is the key here, and the integer that's associated with it is the value. And maybe in this case, the value is the number of that animal that I have in my house. So that says I have 15 cats, 4 cows, 100 ants, and so on. So this is like a set in that the keys have to be unique. You're not going to have cat 15 showing up one place and cat 32 showing up in the same set. This particular one is a hash map of strings and integers, meaning the key is the string. You look things up by the key to obtain the value. So the fundamental operation here would be, you would say, okay, tell me the number associated with cat, or tell me the number associated with pig. So it's a way of looking up. So think of, if you know what a phone book is. A phone book is a map. Okay? It maps names to numbers. Yeah?
The value always.
He's asked, is the value always an integer? It is in this one because we said so. So if you wanted the key to be an integer and the value to be a string, you would say hash map of integer comma string. Yeah?
So the key can't repeat, but can the value repeat?
The value can repeat. And in fact, you see rat and dog have the same value. That's okay. But you're not going to find 2 rats in there. Yeah?
So is it possible to check whether or not a key is in your set? Like if you wanted to check to see if you have sheep in there?
Yes. Yeah. There are ways. I'm not really going into all the methods right now because we're going to look at coding examples. But that's one thing you often want to find out. You might ask, is there a dog in the set? And if there's not, I'm sorry, in the map. If there's not, you put one in. Yeah?
So there's supposed to be a colon between the rat and the egg?
Oh, yeah.
To determine that, okay, just making sure. Because that's how you determine the string.
Yeah, I mean, this is just a picture I made. But yeah, for consistency, I should have used a colon after rat. That was just an oversight. Okay? That's one way of thinking about a map. Here's another way that might be more useful. It's not just, it's like a set. It's also sort of like an array list, like a list. Except the keys are the indexes into the array. So imagine that you know, what you do is you go look and see what's stored in index cow, and you get a 4 out. So you can think of it that way too, as kind of an extension of the list idea where the indexes are strings in this case instead of ints. Yeah?
Is there any order in a hash map?
He asked, is there any order in a hash map? No. No, the order is arbitrary. So the analogy between a hash map and a list is kind of strained because there really is no ordering. But a lot of times you think of it that way. You think of a map as just a way of looking up information using a key. The same way you look up information in a list by using an index. Yeah?
Sorry, I'm just trying to grasp this concept. Up there you have 15 cat and then 15 is pig. Are you saying the certain index and then the 15 is the key to actually access that string?
Okay, back to here. The first thing before the colon in each case is the key. The thing after the colon is the value.
Oh.
So I'm using this to store I said the number of each kind of animal I have, or it could be the age of each kind of animal I have, or whatever. So if you look up ages of animals, you use this. And if you this is just another way to visualize the same thing. Yeah?
So you mentioned the phone book analogy, and so a phone book would be kind of like a sorted hash or map.
Okay, so, right, so the phone book analogy, the names are sorted. And in fact, that's a key difference between a hash map and a tree map. In a tree map, the keys are sorted. We'll actually use that to advantage eventually.
Is it possible to use numbers as keys, or does it have to be a string?
Oh, you can use numbers as keys. It just depends how you declare it. So if you want to have a double be the key into a hash map, you just put double as you say double comma something. So the key type comes first and then the value type. Yes?
Do the keys and values have to be different types, or can they be the same type?
No, the keys and values could be the same type. You could have a map that maps strings to strings. That's pretty common, actually. Or integers to integers. Yeah?
Do all the keys have to be the same type?
He asked, do all the keys have to be the same type? Yeah, the keys have to be the type of that you say they are. So if the key type is string, all the keys have to be strings. Yeah?
Are hash maps mutable then?
He asked, are hash maps mutable? Yes. Meaning there are operations that change the hash map. You can put new key value pairs in, you can remove pairs, you can change the value that's associated with the key. Yeah?
So value
Say again? Oh, absolutely. Value has to be an object. The key has to be an object. Yes?
Can the key and value be the same type?
Absolutely. Key and value can be the same type. Yep?
So value can be repeated and key cannot?
Right. The key cannot be repeated. Okay. Yep?
In the spirit of keys and values, are we going to be going over enums for immutable types or static references?
I'm not sure if I'll talk about enums or not, but certainly not today. So
Okay.
I'll leave that there. Let's look at some of this stuff in action. That's the end of the slides anyway. So, back to the program here. Books. Okay, this is where I want to be. Right there, collections demo. Okay. So I have a method here, my main method, and this is cribbed from, I think, maybe a simple test case that I gave you with assignment 5. What this does, it creates an input stream that's reading Pride and Prejudice. So the project has a package called books that contains prideandprejudice.txt. And this little piece of code right here is a way to open a file that is stored in your project in a completely portable way. Okay? So that when you hand it in, for example, the file will be handed in along with the project and the opening will still work. So I'm not going to dwell on this collectiondemo.class.getResources stream. That's a portable way of opening something in the, that's make your Eclipse projects work when you move from one machine to another. Anyway, I use this to get an input stream that's reading from that book, and then I create a scanner to read from it. And then I can do whatever I want to in here. I can read from the scanner. So the first thing I want to do I want to know how many different characters are in the book. And by characters, I don't mean Elizabeth Bennet and Mr. whatever.
Mr. Darcy.
Darcy, Mr. Darcy. I mean like A, B, C, and so forth. So, as often happens when you're programming, a tremendous number of times, it turns out that you're trying to figure out how to solve the problem. I want to know how many different characters there are. What you should ask yourself is, do one of the collection classes help me out here? So should I make, for example, a list of all the characters? Would that help? If I made an array list that contained every single character in the book. And then, would that solve my problem? What do you think? How long would that list be? It'd be very long. But I don't want to know how many characters. I want to know how many distinct characters there are. So, what would be a strategy? Yeah.
Could you use like a hash map and select each character that we can use and the numbers?
Okay, so he said, could I use a hash map and map each character to the number of times it occurs? I could, but do I even need to do that? Because what do I want to know? I just want to know how many distinct characters there are, not what is the most common. Yeah?
Just create a hash set.
Okay. All right, so what we'll do is we'll create a hash set, and then we'll just throw every single character into the hash set. And then we'll ask for the size of the set. So if we end up throwing 1,000 E's into the set, because of the way it ignores duplicates, there'll only be one E in the set. So that's how I can find out the number of distinct characters. So let's try that. I will just call this method countChars. And we'll pass it the scanner. Okay, so we're envisioning this method called countChars that counts characters, and maybe we ought to do something like print out the answer. So let me do that. And then a nice feature of Eclipse is we can just hover the mouse and it'll say create the method for us. And we'll do that. And it'll at least write the header for us. And then let's look at it and make sure it was right. It's taking a scanner as a parameter. That's good. What's up with returning us an array of characters? Is that what we want to return? What do we want to return? Probably want to return an int. Okay? I want to check this poor laptop and see if it's still streaming. Yeah. All right. So what we said, we'll just go through and throw every character into the set. So what kind of hash set should I create? How should I declare? I got to say hash set of what?
Character.
We'd like to. It'd be nice if I could say char, but I got to spell it that way. Now, one nice thing is about the recent versions of Java is you don't actually have to put the character. You don't have to say hash set of character in the new part. If Java compiler it can figure out which you mean. It knows you mean character because it can see over here that's what you said. So it saves some typing. And I need to import this. It's in java.util. So there we import it. So there's an empty set. When we're all done with this, we're going to return all chars dot size. Size is a method that will tell me how many things are in the set. So what do I need to do to throw every character into the set? Yeah?
Does the new construction for hash set, can it not take the scanner as an input and turn that into a hash set automatically?
Yeah, there's no hash set constructor that takes a scanner as a parameter. Yeah?
You'll iterate through all the scanner's input and store append it to the hash set.
Okay, so he said we iterate through everything and store it in the hash set. The problem is you can't iterate through characters. Alas, yeah?
Oh, sorry. Can you convert the everything in the scanner to a string and then do that?
All right, he said, could we convert everything to a string? We could. We'd have a really long string then.
Yeah.
It's simpler. Let's just do this. Let's say while input has more lines. Let's just make sure that there is no
Has more lines or has next lines?
has next line. Yeah, you're right. There is no next char, so has next line. Okay. So I can get a line at a time out. So I'll say string line equals input dot next line. Now what do I do with the line now? What's that?
Parse it for all the characters.
I got to pull all the characters out. Now, how do I do that? Well, I got to write a loop that goes through the string. But I'm so good at it, I can write a nested loop. I'll write a nice for loop here. And here's where I'm going to do all chars.add line.charadd. Okay. Now, did I get that right? Let's see. I'm looking at one line at a time, and for each line, I go through every character, and I throw that character into the set. Seem good? Yeah.
So the hash set is not going to be linked together; they're going to be separated.
Right. Every character goes in separately. Right. Just think of a cloud of characters floating around. Now, there's one fine point, which is, if we do it that way, we never put the new line character into the set. There's a new line at the end of every line, but the scanner doesn't give it to us. So to fix that, I'm just going to say all chars.add. I'll just do that manually. I'll just add the extra new line in. Now, what do you think the answer will be? I don't know. 100? 50?
More than one.
75. I didn't do that before. Okay. Now, you might be curious as to what they are. I'm curious. So let's just put a printout down here so I can see. And we're hoping now that the hash set class can convert a hash set to a string in a sensible fashion. I'm not even sure what the answer is. Let's see what happens. So I'm going to run it. All right. So we see all the characters. You can see the commas are to separate them. It looks like there's a couple kinds of spaces, an exclamation mark. All the digits are in there, lots of punctuation, a lot of capital letters, a lot of lowercase letters, and there's an underscore. I don't want to count the lowercase and uppercase as different kinds of letters. So how can I avoid double counting uppercase and lowercase? Yeah.
Can you convert them either all to uppercase or lowercase?
Right. So when I add the character, I will just say there's a. That's not what I meant to do. There's a method called character dot. Let's just do two lowercase. And that way, we'll just be adding everything we add. It'll turn all the uppercase letters into lowercase. So if we run this again, now there are only 51. So there's 26 letters. I assume all 26 letters show up. 10 digits and in various forms of punctuation in the book. Okay? So what did we buy here by using a set? What did that give us? What would our program have looked like if we didn't use a set? Yeah?
If we were using a regular list, we might have to check for every character if it's already in the list.
Okay? So we could have created a big, an empty list, and every time we come with a new character, we stick it in the list. That means every time we find a character, we would have to search and see if it's already in the list and then add it. So that's what we got from using this. It automatically checks for us, and it does it efficiently. Okay? So, not too hard to do if you know there's such a thing as a set. These things can really solve you a lot of problems. Okay, let's go do something else now. Let's see, I have a crib sheet up here. How many different words in the book? Okay, well, that's not so hard. And in fact, since we have such a fine method to count characters, surely counting words can't be that different. Now, there's one thing I'm not doing in the interest of time that I expect you to do. What is that?
Java doc.
Yeah, the Java doc. But my typing skills aren't what they used to be, and you don't want to watch me try to type them, so I'll leave them out for now. All right, I want to count all the words in the scanner. So does it make sense to use a hash set of characters?
No.
It makes sense to use a hash set. What sorts of things, what are we going to store in the hash set? Yeah.
Why is it private?
It's private, but well, the honest answer is private because that's what Eclipse suggested. I could, these are certainly very useful methods. No reason for them to be private, so I can make them public.
And the other answer, wouldn't you just have a hash set of strings?
Right. We're going to store words in there, and those are strings, not characters. So I need a hash set of strings. So now I've got to grind through the book, finding words. It's not plural. Finding words and throwing them into the set. So a word, we're just going to call a word to be a token. So we'll just say, while there is a next token, what do we do? I should say this. So you go find a word. What do you do with it? Yeah?
We can make a while loop for while whatever the input that has next. We can just add the next token to the hash set.
Okay, so we have a loop there. While there's a next. While there's a next token, we grab the token, throw it in the set. Then we'll print out the thing and return its length. One thing I really don't like about this method, maybe one of you can spot it. You have? Yeah, what do you think?
Named all characters.
Yeah, all chars is not the best name for a set of words. So let's change it to all words. I mean, this stuff really makes a difference. I don't know if any of you had the experience yet of looking at your program from last week and not being able to understand how it works. But I've certainly had that experience. Okay, so now we're going to count how many different words there are in the set, in the thing. All right, I have no idea. I didn't try this for class. Anybody want to guess how many different words there are in Pride and Prejudice? One? Okay. All right, let's just try it. 13,000 different words. Now, let's see if these are all really different words. Let's see, there's gratified nicely, happiness with a period after it. Which is going to be different from happiness. I bet you happiness is somewhere else in there as well. Carved with a comma after it. Favor with it. So the problem is, it's counting things that we don't consider words. You know, it's including the punctuation with the words. Now, some punctuation belongs in a word, like a hyphen or an apostrophe. Yeah?
But couldn't you write your program to ignore certain punctuation, like after a certain word?
Okay, so he's saying, couldn't we write the program to ignore certain punctuation? Yeah? What's the root of the problem? Where are our words coming from? Yeah?
Yeah, I have a quick question.
Yeah?
So when it's printing out the different words, why is it printing out in that order rather than printing out the very first word, very second word?
Okay, fair question. He's asking, why is he printing out in that order? Well, if we used a tree set, in fact, let me do that. So a different kind of set is a tree set, and I think all I have to do here is change this to tree set, and change this to tree set. So it uses a different internal way of keeping track of the elements in a set. You have to import it. Okay? And we should get the same answer out, but the words come out in a very different order. Now, what order is it obvious that it's using there?
Alphabetical.
Alphabetical order. So internally, a tree set keeps things in lexicographic order, which is a generalization of alphabetical order. A hash set keeps things in an order that works best for it.
It's just random.
Yeah, it's effectively random when you look at it. But in any case, we're getting this problem with double counting words. So 13,059. Now, one source of double counting is the case differences. So remember that 13,059, and let's just put 2 lowercase in here. See, a lot of programming isn't writing a ton of code. It's making the best use of what's available to you. You realize that, I didn't write the perfect program at first here. We're gradually improving it. So now I'm not going to, we won't count case differences. So what was it?
15,059.
Whatever it was, it should be different this time. Is that different or higher?
Lower.
It's lower.
Like 5 or
Okay. All right, so it's lower. Now, what about this problem with all the punctuation that's showing up in here? Yes? He said I could use a regular expression to cut it out. Why is the punctuation being included in the words at all? Yeah?
Because you're counting tokens.
Because the scanner, this is the scanner's business. The scanner is just saying, okay, everything's separated by white space, that's a token. Now, what we can do is after we create the token, we can change what it, so it right now considers the white spaces to be the delimiters between tokens. We can tell it, in addition to white space, consider commas to be parts of, delimiters. Consider periods to be delimiters. Consider, whatever punctuation there is to be delimiters. And then, just like it ignores the white space, it'll ignore all the delimiters. And then we get real words. I'm not going to do that today because I'm just about out of time. But maybe we'll look at it next time. But are there any last questions I can answer about this? Okay, I will see you Wednesday.
John has a way to move me.
Now you can talk.
John.
Hello, now you're going to be at the end of the video.
Sweet.
Stefan. They're in it too.